Hello and welcome to this week's What Were They Thinking? We'll begin with an article coming out of the conversation. This is examining the relationship between autoimmune disorders and the CCP virus, specifically how the virus itself can generate antibodies that are capable of not only attacking the virus, but also increasingly commonly causing reactivity to the host. Not just reactivity in terms of attacking the host body, but causing things like blood clots. These are unexpected and unanticipated consequences of infection, and the fact that they can be far more serious than just the disease by itself is a big concern. To support this initial assertion, the author references their preprint publication, which identifies autoantibodies along with the antibodies specific to the CCP virus and how they are produced at the same time. What they also note is that these autoantibodies are found in the severe cases of CCP virus infection. What they're not yet sure of is exactly how the severity of the CCP virus infection relates to the development of these antibodies. The second news item this week is about long-term COVID-19 infections, or long COVID. These cases of the CCP virus tend to go on for more than 8 weeks after the infection is supposed to have been removed from the body. In some cases, this can go on for months. In one investigation that's still awaiting peer review, 4,000 patients were followed up. 20% weren't feeling better after 4 weeks, which is a pretty significant figure. But then we get to 8 weeks where there's still 190 patients, and at 12 weeks where there were 100 patients. That's 3 months after the initial infection. Statistically, it has the greatest impact on those who are more than 70 years old, at around a representation of 22% of the participants who reported the long-term symptoms. Those between the ages of 18 and 49 represented 10%. This fits with the existing body of research that indicates the elderly, those with comorbidities, and similar are more likely to experience severe infection. Long-term implications of infection are one thing, but what about the cognitive cost? And this is where we have other concerns coming up again. Evidence is mounting that there is neurological damage from an infection by the CCP virus. Some initial research indicates that it may cause brain aging in the range of about 10 years. That's a significant deterioration in cognitive functioning. The problem with this research is that it is only available on a preprint server and has yet to be peer-reviewed. It does fit with other evidence, and the size of the study does give some pause to initial criticisms of that. It looked at a little over 84,000 people who took an intelligence test. What they were able to find from such a large sampling of the population is that those who had the CCP virus had the greatest effect on the decline in their cognitive functioning. The nature of this test is flawed because we don't know exactly what's happened before insofar as their intelligence went, nor do we know if the implications of this are long-term. It is possible that they may see some recovery or complete recovery. The next bit of news is especially relevant when we're talking about infections. It's been said repeatedly that there are many cases of the CCP virus that are relatively asymptomatic. These asymptomatic cases are underdiagnosed and underrecognized because they don't have the same impact on the host. Examination of these asymptomatic carriers of a sort would indicate that they're also more vulnerable to being reinfected later. Specifically, they lose their antibodies that much sooner than those who have had a more severe infection. The research is being done in Britain and was looking at exactly what's happening with their population. They found that there is a big difference between those between the ages of 18 to 24 and those aged 75 and over. Younger people lost the antibodies slower than those who were older, which makes sense. Younger bodies tend to be more resilient to infection overall. The big caveat to that is simply this. Healthcare workers who have been prospectively repeatedly exposed to the CCP virus did not demonstrate the same change in their antibody levels. In fact, they remained high throughout the entire period of the study. This change in antibody level may be reflective of a trend that we'll see from vaccines, but it may also explain why some people are prone to reinfection. As we've mentioned previously, there is some risk that with a relatively asymptomatic infection, that the immune system simply won't be rallied to the same point where it develops a strong enough response that it can maintain and then fight back against the virus and remember to do so next time. If that is the case, then it explains some of what we're seeing with this change in antibody levels. It explains why we're seeing reinfection, especially in asymptomatic people, and why vaccines may need to be modified to accommodate this, whether that's a schedule of vaccinations or a wholesale change to the formula used. Next is an interesting story about where infections are coming from in America, specifically within Los Angeles. The Los Angeles County health officials have finally come down and said that at least 15% of CCP virus infections are as a result of dining at restaurants. The health department did add some important points to this. The first is that if people are dining indoors, they are in closer contact with others, often without a face covering, they're not members of their household, and they are engaging in conversation. This means greater risk of infection overall. Going now from CCP virus-related news to an interesting examination of human anatomy, and specifically human pathology. Scientists often try to recreate various pathologies using cells. This can often be difficult when we talk about a mixed culture of cells. What these researchers have done is not only create a mixed culture, but try to replicate the pathology of an aneurysm. Aneurysms occur when the blood vessels in the brain are overpressurized, breach, and blood begins to move out. Before this happens, you get a small bulging or ballooning in that area. This is what can lead to the rupture. The aneurysm itself is that ballooning process. As the blood pressure builds up in that aneurysm, it can eventually break out. That then leads to pressure on the brain. Pressure on the brain is extremely bad for cognitive performance. The method they've used to develop this is really impressive. It combines modern technology and some of our older, more reliable laboratory techniques. They've gone and 3D printed an aneurysm-shaped culture dish. They've then added various membranes and cells to this and started growing them. This created a scaffold that could effectively completely replicate the aneurysm. Unlike past research into this time they're using human cells and creating a living structure. That distinction's important if we're trying to understand what is happening in the human brain, for instance. Discoveries here in how the human brain could respond to an aneurysm might allow for clinical discoveries that will be useful in treating it in the future. At the moment, there aren't many options as far as treatment goes, and they are nearly all extremely invasive. In other biological news, we want to talk about a weird discovery. Now, you may have seen this image coming up on Facebook and thought, well, surely it's just a scam. Well, no, not quite. The snake comes from Palm Harbor in Florida, and it is real. It's a rare example of various pathologies, but specifically one known as bicephaly. Pathology may not necessarily be the right term, but it's certainly not normal. It's an abnormal development during embryonic development, and it's a consequence of a failure to separate when twins are developing. In humans, you might see this in chimerism, where the twins become one person, or conjoined twins in other cases. And that's something along the lines of what we're seeing here. The snake in question has been taken care of by the Florida Fish and Wildlife Conservation Commission. They'll help to keep it alive, as the axiom goes, 2 heads are better than 1 doesn't always apply. In fact, in the wild, having 2 heads with competing interests can often make it difficult to feed, fight, and flee. For this reason, animals with the 2 heads like we're seeing with this snake often don't survive. While on the subject of weird animals and survival, we should take a look at the naked mole rat. The naked mole rat is really weird as a creature. It can survive in weird environments, doesn't really need to see, tolerates high levels of pain, doesn't need oxygen for periods of time, resists cancer, and so on. All kinds of weird abilities. One that's not mentioned anywhere near as often is the penchant towards kidnapping other naked mole rat offspring and turning them into slaves. The naked mole rat colony is somewhat bizarre itself. In fact, it behaves more like an insect colony, one reproductive queen and a whole lot of workers who are more than less sterile. And that seems to be what's happening with the offspring that they kidnap from other colonies. They will take them back to their own and simply turn them into sterile workers. In other weird news and weird behaviors, it's time to put rest to the idea that a Twinkie could survive forever. A recent study of Twinkies that have been kept in a basement for 8 years has come up rather untasty. The initial images were posted online of the discovery of some unintentionally stored Twinkies. These were sampled and turned out to taste rather terrible. This led to other researchers contacting the person who posted the images and asking if they happened to have any more for research purposes. In fact, they did. This led to the Twinkies being sent out to microbiology researchers who were trying to figure out what fungi were growing in there. And it was fungi that they found initially, specifically Cladosporium. This is a fairly common kitchen mold. From the images you see here, you can tell that it's unlikely you'd be able to keep a Twinkie for very long. Despite how many preservatives are in them, they simply cannot be stored forever. While finding microbes, and particularly fungi, in Twinkies is slightly surprising, it's not all that unexpected. Theoretically, any food that we can eat should be a hospitable place for fungi to develop. Our next story takes us to space, but still looking at places that could be habitable, and particularly an Earth-sized exoplanet. Exoplanets are those planets that are outside the normal part of the solar system that we're familiar with. In fact, they're normally circling suns that are significantly smaller than our own, smaller and less hot. This decrease in size and heat has a number of effects on things like gravity, but also how warm these planets are. That warmth and location with proximity to the sun are all very important factors when we look at whether or not they could possibly be habitable. It's worth remembering that Earth exists in something known as the Goldilocks zone. If it was any further from the sun, the Earth would be too cold for life. Any closer and it would be too hot. Then you also have to account for things like radiation, protection from the gravitational field of the sun from asteroids, and so on. Little factors that individually aren't massive, but that collectively, once we begin accounting for them, mean that life as it is and where it is incredibly unlikely and a success story. Our final news item this week regards NASA's attempt to sample an asteroid. NASA's had some difficulty this week with trying to get an asteroid sample back from where it came. The issue it faces is initially that it had collected far too much. This led to the probe beginning to leak the sample. Having only taken on so much room within the probe itself, overstocking it would be a problem. And this is where they've hit their first big issue. A successful sampling is great news, but they needed a way to contain it, and the container they were using had been kept open by the sheer amount of material they had picked up. This meant the incredibly difficult and expensive probe was losing material into space, material that could not be readily replaced. That meant they also had to find a way to close the hatch that the samples were attempted to be stored into. Despite having to shift things around and having lost some of their sample already, they have still successfully managed to get hundreds of grams of space sample from the asteroid into the probe. This is far and away beyond what they had hoped to achieve, and it means that the probe, known as OSIRIS-REx, has been successful. It's expected to return around this time in 2023. That's all the news we have for you this week. Thank you for watching. If you found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.